Welcome to The Explainer. Today, we're diving into a really fascinating, kind of weird paradox at the heart of modern AI. We've got these models that seem like absolute geniuses, but it turns out that genius can be incredibly fragile. So how can an AI that passes the world's hardest exams fail at a task a child could do? Let's get into it.
So this is the central mystery we're talking about. An AI can ace some of the most difficult professional exams on the entire planet, showing off this incredible knowledge and reasoning. And yet, if you give that exact same AI a super simple repetitive task and just make it go on long enough, it eventually just breaks. Why is that?
Now, your first gut reaction might be to think, okay, the AI just isn't smart enough, that this is a failure of its core reasoning. But the research we're digging into today shows that's actually the wrong suspect entirely.
To really get this, we have to pull apart two key ideas: planning versus execution. Planning is knowing what to do. Execution is actually doing it. And here's the twist. These models often have a perfect plan. They know exactly what they're supposed to do. The failure happens in the simple, step-by-step act of carrying out that plan.
So just think about that for a second. This is not a failure of intelligence. The AI knows the rules of the game perfectly. It just sort of gets confused as the game stretches on and on. It's an issue of reliability, not reasoning.
So, if it's not a problem with reasoning, what is the real culprit here? Well, researchers uncovered this subtle but really powerful feedback loop that just trips these models up again and again.
They call it the self-conditioning effect. To put it simply, when an AI makes a mistake, that mistake becomes part of its own memory. And since the model is always learning from what came before it, its own past errors make it statistically more likely to fail again. It's a total downward spiral.
Let's actually see this in action. Imagine an AI with a perfect track record, no mistakes so far. As you'd probably expect, its accuracy on the very next step is nearly flawless, right? Something like 98%. But watch what happens next if we intentionally inject just a few errors into the AI's history without changing the current task at all. Its accuracy on that exact same step suddenly takes a nosedive.
And as more and more errors pollute its context, the model basically gets flustered. It starts conditioning on its own failures, and its accuracy just plummets. It's the machine equivalent of making one unforced error in tennis, then getting tilted and making 3 more right after.
And here is the real kicker. You'd think, okay, a bigger, more powerful model would fix this, right? Wrong. The research shows that even the largest, most advanced, cutting-edge models fall into this exact same self-conditioning trap.
But there is a solution, and it's both incredibly simple and profoundly powerful. It's all about giving the AI a moment to just think.
So what does thinking actually mean for an AI? Well, instead of forcing it to spit out an answer immediately, you prompt it to generate its reasoning process first. It creates an internal monologue, or what researchers call a chain of thought. It's kind of like showing your work on a math problem before you write down the final solution.
The difference this makes is, well, it's staggering. Without thinking, a state-of-the-art model fails after executing just 2 steps of a simple, repetitive task. 2. That's it.
But when you let that exact same model think first, let it generate its chain of thought before it acts, the number of steps it can complete successfully just explodes to over 200. That's a 100-fold improvement. So why does this work? Well, thinking completely shatters the self-conditioning feedback loop. By focusing on its internal reasoning for the current step, the model effectively learns to ignore the errors in its past. Its accuracy stays high, and it creates a virtuous cycle instead of a vicious one.
This discovery completely reshapes how we should be thinking about the next generation of AI. It suggests we've basically been measuring the wrong thing this whole time. It's not just about raw intelligence anymore.
Our traditional benchmarks, the ones that mostly test short, single-answer questions, they might just be an illusion. We see progress slowing down on those tests and think AI is hitting some kind of wall. But we might just be looking in the wrong place.
The real race, the one that's going to unlock massive scientific and economic value, is for what's called long-horizon execution. You can think of it as a measure of AI endurance. How long can an AI reliably execute a plan without making one critical error?
And we can now see this new benchmark in action. The current top-tier models, when they're allowed to think, are pretty impressive. Claude, Gemini, and others, they can all handle hundreds of steps in a row. It's a huge leap forward, but it's really nothing compared to what's coming next. Because then, we get a little glimpse of the next generation.
there's a model codenamed Horizon, which most people believe is GPT-5, and it isn't just a small step forward. No, it's in a completely different league.
It can execute over 1,000 steps in a single turn without failing. That is more than double its nearest competitor. This isn't just an improvement, it's a phase shift in capability. This is the new gold standard for what a powerful AI looks like.
So, this all leads us to one final huge question. We've just seen that the simple act of thinking can transform a fragile genius into a reliable workhorse. The goal isn't just making AI smarter anymore, it's about making it more deliberate. So what happens when we can build AI agents that can maintain a chain of thought not for a few hundred steps, but for thousands, or for hours, or even for days? What impossible problems are we about to solve then?